Hey everyone, so today we're doing something really cool. We're going to build a private, powerful AI workforce that runs entirely on your own machine. Yeah, you heard that right. We're talking full control, zero data leaks, and absolutely no surprise API bills. This is what we call the sovereign stack.
So let's kick things off with the why. You know, for some industries, this isn't just a cool tech project, it's a necessity. If you're dealing with sensitive data, think financial records, patient info, secret company strategy. Control isn't just a feature, it's a flat-out, non-negotiable requirement. Sending that stuff to a third-party cloud? Often impossible because of regulations like GDPR or HIPAA.
You know, the choice really boils down to this. Are you just renting your AI's grain, or do you actually own it? Let's break it down. On one side, you've got the cloud APIs. They can get pricey, fast, especially when you have a bunch of agents running complex jobs. Plus, you're fundamentally trusting someone else with your data. But on the other side, with a local setup, you get total privacy and complete control. Your AI operations stop being this unpredictable monthly expense and become a fixed asset you own.
Okay, so to build this system, we really need to get our heads around its two fundamental layers. I like to think of it like directing a play. You need a director to manage the actors, right? And you need the actors themselves to actually perform. Well, in our stack, we have an orchestrator and an engine.
So first up, we've got CrewAI. This is our project manager, our orchestrator. It's this fantastic Python framework that lets you define different AI agents, each with its own specific role, goal, and even a backstory. CrewAI then acts as the director, telling all these agents how to work together to get the job done.
And that brings us to the second layer, Ollama, the inference engine. So if CrewAI is the director, then Ollama provides the actual talent, the brains, that do all the heavy lifting, all the thinking and processing. It's an amazing service that makes it super easy to download and run these powerful open source language models like Llama 3 or Mistral entirely on your own hardware.
All right, let's get into the first practical step and see how this all comes together. We need to get our inference engine ready for action. Basically, we need to give our CrewAI agents a brain to work with. And we're going to do that by setting up Ollama.
And you'll be happy to hear it's a super simple two-step process. First, you just pop over to ollama.ai and download the application for your operating system. Once that's installed and running quietly in the background, you just open up your terminal for step 2, downloading a model for your agents to use. For this explainer, we're going to pull a really nicely balanced model like Llama 3.18b. So in your terminal, you literally just type Ollama pull Llama 3.18b, and Ollama takes care of everything else. This 8 billion parameter model is great because it offers this fantastic mix of performance without needing a supercomputer. It's perfect for running on a modern laptop or desktop with something like 16 gigabytes of RAM.
Okay, with our model downloaded and ready to go, it's time to scaffold our CrewAI project. Now, we're not just going to throw a bunch of code into a single file. No, we're going to use the modern recommended structure. And this isn't just about being neat. It's about building a system that's easy to maintain, scale, and work on as your projects get way more complex.
We just use the CrewAI command line tool. A single command creates a standardized project structure for us. And trust me, this is a total game changer because it separates our configuration from our actual code, which sets us up for success right from the very beginning. And this new structure is so powerful because it lets us define our agents declaratively. So instead of writing these big, complicated Python classes for every single agent, we can use a simple configuration file, a YAML file, to just describe each agent's role and goal. This makes the whole system incredibly easy to read and modify. You can tweak agents or add new ones without ever touching the core logic.
And we do the exact same thing for tasks. We define them in their own separate file. So for example, we could create a research task and clearly describe what needs to be done and what that final output should look like. This separation of concerns, well, it's a software development best practice for a reason. It keeps the project clean and makes it so much easier to go from a simple 2-agent crew to a complex, multi-layered AI workforce.
Okay, this is the moment. This is where it all comes together. We've got our orchestrator, CrewAI, and we've got our local engine, Ollama, running with a downloaded model. Now, we're about to connect them with just a few lines of code. So, look at this. The whole magic trick is in this single line of code. In our Python script where we set up the crew, we initialize our language model. But instead of pointing to some cloud API, we tell it the model we pulled, and then we set the base URL to our local Ollama server, which runs on port 1143.4 by default. That's it. That's the whole thing. You've now told CrewAI to use the brain that's running right on your own machine.
Okay, now for a little reality check. A real-world tip.
Running agents locally is incredibly powerful, but you might run into a really common and kind of frustrating problem, especially when you're just getting started.
Have you ever had this happen? Your agent just seems to be thinking forever without actually producing a result? It feels stuck, right? Like it's repeating the same thought process over and over. That, my friends, is what we call the local loop of death, and it's probably the biggest headache when setting up local agents for the first time.
So, why does this happen? Well, it's because these smaller, local models, like our 8B model, can be a little less reliable than their giant cloud-based cousins. The CrewAI framework is listening for a very specific string in the agent's output. Final answer. That's how it knows a task is done. But if the model gives you the right information but forgets that exact token, well, the framework thinks the agent is still working and tells it to try again and again and again, creating an infinite loop.
Luckily, the fix is surprisingly simple. You have to be extremely explicit in your prompts and your task descriptions. When you're working with local AI, your prompts basically become the guardrails for the whole system. By giving the model crystal clear instructions on its role, its goal, and especially the exact format for its final answer, you're helping it succeed. You're giving it the structure it needs. So, what's the big takeaway here? Well, building a completely private AI workforce is not only possible, it's actually pretty practical. You just have to remember a few key things. Own your stack for privacy. Use a proper structure for projects you can actually maintain. Make that simple connection with the base URL. And, probably most important, prompt explicitly. Give your local models the guardrails they need to get you the results you want.
And that really brings us to a final thought. Now that the technical, the cost, and the privacy barriers are gone, what new possibilities are open to you? What sensitive, high-stakes workflow in your business is suddenly ready to be automated? The sovereign stack is yours to command.